next speaker. I would like, Prof is here. I would like us, Professor Uji to really hear this presentation, because I know he's right now undertaking, or we are undertaking a research on almost similar topic. So the topic is a comparison of stabilized earth interlocking bricks versus comprised stabilized earth brick. The speaker is Stephen Makama. Architect Stephen Makama.
The presenter, sorry, can I have the final poster? Hello? Up there? Final poster. Great Josites. I'm very happy to be here. I have the privilege of having my BSc supervisor, my MSc supervisor, Professor Zanzan. So I'll just observe all other protocols. Actually, it's not really paper, so to say. It's a demonstration. Is the slide there? It's just one slide. Final poster. Okay. Unfortunately, again. But the reason why I just wanted to talk about this very briefly, is if you look at the topic, actually it says to SIEB or CSEB. But from the poster, it has been an academic exercise I've been undertaking on compressed stabilized earth brick in Nigeria. So for some of you who do a lot of reading, this is taken from Shakespeare, to be or not to be. But the essence of this infographic that you see there has to do with the fact that in 1992, the federal government of Nigeria, through the National Commission for Museums and Monuments, Ministry of Cultural Affairs, and the French government, they developed a partnership to set up the Center for Earth Construction Technology, what we call MOD, clay. You know, when the Western people want to describe the architecture of Africa, probably traditional architecture, they call it MOD. But some of us have been very not happy with that description. It's not MOD. MOD is just, it gives a derogatory kind of feel or listen. So this center was set up in 1992 to explore these issues that have to do with low-cost housing and issues around everybody wants to own a house. But unfortunately, especially now, how much is a bag of cement now? It's almost 10,000 naira or more. So the idea was using the different forms of mud. Let me use that word. You have the compressed bricks, you have rammed earth. There are different alternatives that you can use. But unfortunately, I don't know why the center seemed to concentrate on compressed, stabilized earth brick technology. And from 1992 to about 2004, there was a lot of activity. There were many buildings that were built. People were excited. And it was around that time that I picked interest also. I would leave school here and go straight to the museum where the center was. And somehow I formed a kind of relationship with one of the late former heads of center, Architect Valentine Ogususi. So there was a lot of activity around that time. But then from 2004 to 2014, the momentum seemed to be lost. It was going down. You know, this particular session would not allow me to talk about it in detail, but I just want to just catch some small, important focal points about this technology, about this issue. So from 2004 to 2014, yes, there was a bit of activity, but unfortunately, due to many factors which I can't go into now, the momentum was lost. From 2014 to about 2024, I could say maybe nothing happened. But I remember in 2016 and 2017, there were some workshops that were held, and then in 2022, and it was under the focus of the compressed stabilized earth brick. So I want to make an important point here. I found that out in 2022 when we had the last training. It was two professionals from Nigeria here, just that traveled to South Africa under the sponsorship of the French embassy to go and train South Africans on compressed stabilized earth brick technology. Hold that thought. Years down the road, I don't know any of you have ever heard of hydrofoam. Hydrofoam. You see it on DSTV display. That was a result of the South Africans buying into this technology that we exported to South Africa, and they appropriated it and they developed it. And so the stabilized interlocking earth brick is, I can say, is the pilot project, product. Somehow people seem to, Nigerians, for the few people I met, seem to gravitate more towards the stabilized interlocking earth brick. What is it? It just works on the principle of, I don't know, how many of you know about Lego? These are things we use as kids. They're just toys. You just fix them up on each other and then you build so many things. So that is somehow the basic operating principle of the stabilized interlocking earth brick. They tell you you don't have to use cement, mortar to do all these things. And so it seems very novel, nice. But personally for me, I believe it's not very flexible. It's not very flexible. There are so many restrictions that you encounter when you're using it. But then, as the theme for this symposium says, reimaging architecture for a sustainable future. We need to reimage architecture. And one of the ways is going back to each and every one of these different aspects of utilizing mud or earth. And so we're just going to do a very short demonstration of how to produce one of these bricks that you see. Ima, could you carry this? Just to show them. Ima, just carry this. This was produced, I think, about 2 weeks ago. I produced it on a site somewhere. This is what we're going to do right now. It's a very simple process. We have cut out so many things. Identifying the soil, testing the soil, preparing it to this stage. So we're just going to produce one or two. I don't know. Can you all see a bit of, can you see the stage here? Okay, Ima. So, prepared the soil. We got the soil. We tested it. We believed it was appropriate for use. And so we're going to place it into the machine. The process is you get the soil, you add a bit of cement. Now, the convention is pretty standard. You are looking for 75% soil, a bit of sand, a bit of clay. There's some things that you might not be able to know, learner. But for people who are in it, we can just look at it and then be able to determine. But in the extreme circumstances, sometimes you have to go all the way to the lab to do testing. But like I said, for people who are in it, you can look at the soil and tell the person who's going to deliver it, bring me this amount of soil, this tipper load, okay? Soil has already been sourced. Soil has been sourced. It has been sieved, okay? That's a part of the preparation. And so we're going to put it in the mold and then we're going to press it. Ima? Normally, sorry, can I have one or two students who are willing, who want to learn how to, just one or two boys, please. Please. You can make a living from making these things. Just, Ima, such way. we'll tell you what to do. Ima, tell them what to do. So this is a fabricated machine. I think it's called the SB version. There are different types, from the smallest to almost the biggest. In fact, one of the innovations has been that we have a mechanical one. This is the manual press or the manual machine. No, it's okay. So this is the process of compressing. That's why it's called compress, stabilize. Stabilize is just the addition of the cement, lime, whatever. The stabilization is to help it. You know, anything clay, anything mud is susceptible to attack by moisture. So the idea is you compress it. The compression on its own will not may not give you what you want. So you add a stabilizer. So the stabilization and the compression at the end of the day gives you something like this. And you can decide to build a house with a single wall, single thickness, double wall, triple wall, whatever you want. But the idea is you want something that is low cost, easily available, affordable, and just, you know, a whole list of advantages. See how simple it is. But unfortunately, there are some technicalities that kind of drive people away from it. But this is quite a smooth technology, if I may use that word. So I know some of you might want to ask some questions. You can get about 100 bricks. We recommend 80 from a bag of cement. Hello? A bag of cement, you can get 100 bricks. But you see, there's another catch again. A bricklayer does the work of laying bricks. Okay? A mason normally does masonry, stone, blocks, and everything. But what normally drives people away from this is the level of attention that is needed. You know, you don't just lay bricks anyhow. It needs very careful work. So it's easy for a bricklayer to do the work of a bricklayer and to do the work of a mason. But it's a bit difficult for a mason to do the work of a bricklayer because he's always in a hurry. He wants to do everything. He wants to lay this number of blocks to finish it. So it needs very, very careful work, very careful attention. I think there's not enough laterite. So that's why it's soft. There's not enough laterite. So it's quite interesting. And one of the things that I get when people want to build a house with something like this, they say, is it bulletproof? Unfortunately, that is our reality in Nigeria today. You know, the lack of security. So if somebody wants to stay in a house where he believes he's secure inside and outside. So yes, this is bulletproof. Okay? We'll complete just complete the... by the way, the Center for Earth Construction Technologies is located within the museum complex in Jos. So in case I'm hearing about some students going for a visit, so maybe that can be part of your visit. They have a library there that you can visit. They have books, they have materials, lots of things. In fact, that was what used to keep me, you know, busy. I'll leave here after lectures. Well, not here, the temporary site, and then go and spend the rest of the day in their library there. There's a lot of material. There are people there you can ask questions. There are technicians, there are architects. Okay? So I encourage you to visit the center located in the museum complex. Stand behind it, stand behind it, stand behind it. It's okay. So as you can see, the people who are doing it, they just started now. And probably if they produce up to like 100, 200, they will become, you know, experts, so to say. So this is not maybe the best quality that we can get. But you can imagine, in a very, very standard institution, you have a machine, because this one I think is single compression, but we have machines that have improved, which are double compression. So the density, the compactness is a bit more than, but you can use this. You can use this without any negative consequences. So we'll just finish the lecture. Will it be enough, Ima? Will it be enough to press? Will it be enough? Yeah, just gather everything. Yeah. So I think basically that is it. That's about it. Thank you.
Thank you very much, Architect Stephen. We have all seen it practically. One good thing with architecture is theory and practice. We are getting the theory here, but we need to go to site and learn and practice the profession. Because if you only have the theory without the practice, you will never make it as a master architect. Thank you very much. I would like to, first I will call on Professor Uji to make his comments or ask questions.
Thank you very much. Architect Makama, Wolfgang. Wolfgang. Huh? Is that how you pronounce it? Okay, that was a good presentation. Incidentally, this is an area I'm also interested in. I noticed that you are listening to me. I noticed that you talked about comparison between stabilized earth bricks and stabilized interlocking brick. I was expecting to see interlocking bricks there, but maybe you need more time to bring interlocking bricks. The whole idea of stabilization is to impregnate the soil with some quantity of cement to enable the binding to hold in such a way that the bricks can stand. If you stabilize it with maybe 6% of quantity of cement, as soon as it comes out of the silver ram press, you can stand on it. You can stand on it completely. I used it to build a small hut in my place. It was 6%. I don't know whether you mentioned the percentage of stabilization you were using. So you can stabilize with 4%, 6%. If you want to build a story building, you can stabilize with 8%, 10%, things like that. It depends on what you actually want to achieve. And so if you, I don't know at what point, you need to sieve the laterite too. It can't just be scooped like that. You have to sieve it to get the kind of grain that will bind very well. You remember that the cement, the way it is actually like it is sieved. So if you want to achieve very strong binding, you need to sieve the laterite to achieve maybe 4.75 grain or something like that. And then stabilize it with the quantity of cement that you want. You have to state it very carefully. You have to state what you want to do with it. If it's just an ordinary small hut, it's no problem. 4% will be okay. But if you want to build a bungalow, maybe 6% stabilization. And if you want to go up, story building, 8%, 10%, 12%, things like that. We are working on, I hope you'll be here tomorrow. We are working on interlocking bricks using plastics, PET, polyethylene terephthalate. This plastic waste, these bottles we're using to drink water now, we're using them, boiling them to molten point, and mixing them with laterite, sometimes with sand, and so on. But we're actually using interlocking brick. So I hope all of you will be here tomorrow to watch it. The kind of thing we're here now is to create a problem for us. So we will demonstrate, we'll bring the bricks, we'll bring the mold, we'll bring the, and so on and so forth. But it was a good presentation. Thank you very much.
Okay, sorry, sir.
I hope you permit me to leave. I have some work.
So, sorry, sir. The issue of stabilization, it has been... Hello, sir. The issue of stabilization, tests have been carried out, and we found that 8% is enough. Anything more than that is a waste. Less than that won't give you what you want. But 8% is the standard stabilization that has been, through tests and everything, we found out that that is okay. 8% is okay. And the idea is you can have 0%. This would have been 0%. That white thing you saw, it was supposed to be cement, but I used carbon sludge waste. Carbide sludge, sorry. So the idea is external walls from the DPC level, from the German floor level to the window sill level, you can have 8%. But from the superstructure, you can have less than that or even 0%. And then the partition walls in the inside, you can have 0%. Yes, sir.
Okay.
Thank you very much. Thank you for allowing me to just say some few words. I actually did a comparative analysis of compressed earth and concrete blocks to ascertain which one is more viable for low-cost housing, and discovered that it's way much better. And the truth is that the challenge we have as architects is that we need to educate our clients. Most of them feel this will make them look like a poor man. So we need to educate them and encourage them. There are people that keep saying, I want to build, and they've not been able to start building because of the cost of the concrete blocks and the cement. But with this, you can still achieve something very beautiful. I think we can begin to think as architects, designs that we can come up with that will be irresistible using the compressed earth. Thank you very much.
Okay, thank you so much, sir.
Thank you.
Thank you, Architect Makama, for taking your time to market us. Yes, thank you so much. You have done a good job. The thing I want to add to what you have just said is the issue of compressive strength. It all depends. Some are 8 tons, some are 9 tons, some are 12 tons. The strength of the compression matters much also, most especially to do with the ones outside, because of the rain. If it's not compacted very well, the rain will pierce through it and then it will not bring it down. So it's very important for us to know that aspect also. As you said, before the prof spoke, I wanted to say that you have the stabilization of 0%, as just what we did here. Maybe the internal walls can take that 0%, but the external wall, you can still go for up to 8%, as you said. The highest 8%, that's the truth. If you go beyond 8%, you might not break even. The cost might be equal to that of concrete. So that's how that is done. And also one good part of, or what we're supposed to observe also when we are building compressed earth bricks, we make sure that our eaves outside must be long. It's not normal that 600 or thereabout. It has to be longer than that 600 so that the rain will not really disturb our building. So, but you did well. Thank you. Please come to the museum. We have a lot of things in the museum.
Yeah, we make appointment and get to that place. Yeah. Okay, you want to respond?
Okay. I forgot to mention this, the time was very short. You have options. You can leave the brick, the wall, the external wall, you can leave it, we call it barefaced. You can leave it like that. As long as you do a proper stabilization, stabilization and compression, nothing will happen to it. But then additionally, we have what we call the finishing. You go and then you touch the joints, okay? And then you can use the same laterite, this same thing you're seeing. Mix it, yes, with a bit of water and a bit of cement, and then you can use it to paint in coat. So you eliminate the whole issue of painting, plastering. You don't need to plaster. You don't need to paint. And one of the things I should have mentioned was this issue of indoor thermal comfort. The conventional wisdom is that if you do a proper design, proper windows, this need for artificial ventilation or whatever is not necessary. You have a cool environment when it's hot outside, and when it's like in Jaws, this cold weather, When it's cold outside, it's warm inside. So it has a lot of advantages. Thank you very much.
Explanation. So we can see we have the theory, we have the practice. So we are complete. Actually, this even calls to my mind that especially the young ones coming, the young architects, or the architect in practice, you can specialize in building with these stabilized bricks only. When clients come to you, try to convince them this is cheaper and also aesthetic. It has beauty, you know, it has strength, and it's you get it cheaper than when you use the common concrete blocks we see all over the place. Honestly, this will make you establish yourself. You people acknowledge your petitions. People will come to you. You have clients that only your design is only using stabilized bricks. Or you can, architects can come and collaborate. Establish practice only applying stabilized bricks. So these are the ideas that we're supposed to be, for us to be generating in a colloquium like this. It's not just for you just to come and sit down, you don't learn anything. At least even an idea can just come to your mind. Why not? Don't we come together and do this thing? Why not? Let us do this thing. Let us find out. It's commitment. That is it. Thank you very much. Any other contribution or comment on this? No. Okay.
Thank you. Just want to emphasize the quality of the stabilized earth brick. It has a very good thermal capacity. It can store heat. It can act as a sink heat. It's much better than concrete block. Though it has a disadvantages, like tensile strength is rather weak. Thank you.
Okay, thank you very much.